In this video, we are going to determine the height or the thickness of a piece of aluminum foil. So not this way, not this way, that way. So we're going to determine that using some less than obvious approaches. The most obvious approach would be to try to measure it, but it's too thin, so you're not going to be able to get a good measurement. The other way to do it would be to stack up, maybe 100 sheets and then measure that and then divide by 100, but you don't have 100 sheets, so you're going to have to do it this way. So we're going to use chemistry to figure this out. So we have some pre-lab questions. The first question is, how many centimeters thick do you think the aluminum foil is? I'll give you a hint. It's less than 1. How much less than 1? You write down what you think. There's no right or wrong answer. These are pre-lab questions. And then the next question is, if you were to think of the aluminum foil as, think of it as a rectangle, right? Or a three-dimensional, whatever. How many atoms would you have to stack one on top of the other? Right, I gave you a couple examples. How many atoms would you have to stack one on top of each other to get that thick? All right, and that's what we're gonna figure out today. So your first step, and then you write down your guess here, what you think. Your first step is to use this block and determine its density. So this is an aluminum block, we're going to determine the density. So the first thing we do is we weigh the block. So this block weighs 34.1 grams. And the next thing is we are going to determine the volume of the block. So the way we do that is we measure the length, then we measure the width, and then we measure the height. So you get 7.5 by 2.5 by 0.5, and that gives you the volume. The next thing you're going to do is use the density formula to determine the density and write that down because we're going to need that for the next one. We're pretty much done with the block at that point. The next thing we have to do is weigh the foil. So we put the foil on the scale, 0.4 grams. Next, here's where we get a little fancy. So we are going to use the density of the block that you just calculated. Then we are going to use the mass of the foil, 0.4 grams. Now we're going to figure out the volume of the foil. And the way that works is pretty simple. You are going to measure the length, which is going to be 9. The width, which when we measure it is 7.6. And then the height, which is what we don't know. So we're going to go 9 times 7.6 times x, and this is going to equal 68.4x, which we put over here as our volume. And now you're going to solve for x. So it's going to be your density equals 0.4 over 68.4x. Make two fractions, cross multiply, solve for x, and you get the height of your foil. It's going to be something along the order of 0.00 something. Okay, so that's the height of the foil in centimeters. So you can go back and look at your pre-lab question and see if you were anywhere near the right estimate. The next thing you're going to do is you're going to take your answer for the foil and you're going to divide by the height of an atom, which is all these zeros. So that's the height of one aluminum atom. So you're going to do 0.00 something, divide it by the height of a foil, and you're going to get a very large number that represents the number of atoms. So then you can go back and check and see if your calculated number of atoms is anywhere what you thought it was. Next, percent error. So you're going to determine the percent error for the height in the number of atoms of the aluminum foil. The accepted value is 60,000 atoms. So when I did this lab, I got 60,000, so we're using that as our accepted value. Your answer here for the number of aluminum atoms is going to be your measured value, and then you're going to do a percent error and show me all the work based off that. The next thing you're going to do is you're going to see if there's any error in your density for your aluminum. In other words, if you go to table S and you look up the density of aluminum, that is going to give you your accepted value for the height. for the density. And then if you go back to step 1, when you calculated the density of aluminum, that's going to give you your measured value for the density of aluminum. Do a percent error. There's 2 more questions at the end. Basically, where was the density of the block of aluminum able to be, why were you able to use the density for the block as the density of the aluminum foil? Because that's what this step here really assumes. We use the block to get the density because it's easy to work with, but then we applied it to the foil, which is not easy to work with, which is how we were able to do this. Why does that work? There's a very easy and obvious answer. Hopefully you figured it out. And number 4, what were 2 sources of error in the experiment? I don't want to hear calculations. That's not a source of error. We assume that you can do the math right. So I'm talking about sources of error in the experiment. One giant hint should probably be in your percent error calculations to see if any of them were wildly off, especially if it was early in the process, like calculating the density, then your answers will be skewed from there. So 2 sources for error, and that will conclude this lab.